Hi everyone, this is a video on function properties and function composition for my X203 IA application. So I got this problem from one of the exam, which we have two functions, f and g. We know that f composite g is onto. We know that f is 1 to 1. We want to prove that g is onto. Okay. First of all, what it means for a function to be 1 to 1. It means that every input must have a unique output. So in our case, we have f from b to c. So for all, let's say B1, B2 in the domain B, if f of B1 is the same as f of B2, the output are the same. This can only happen if B1 is B2 because the output is unique, right? What about onto? Onto means everything on the codomain has a corresponding input on the domain. Okay, so in this case, our codomain is B for function g. So for all B in B, there exists an A in A that correspond to this B, right? Such that g of A, this function g will bring this A to that B. Okay, so don't worry about memorizing this. I think it's more important for us to understand what it means than because if you understand what it means, you can easily write this mathematical statement out during exam. But you do need these two for us to prove something that related to onto and 1 to 1. Okay. So next one is composite function. Composite function basically means you take the output of the inside function to use as an input to the outside function. Okay. So in this case, we have hash of, let's say, x is we first find g of x and then we feed it into function f. Okay, so in our case, we have a to b by function g, and then from b to c by function f. So a composite function f composite g means g followed by f, okay, from a to c. And we know that f composite g is onto, which we already know what it means to be for a function to be onto. I just need to replicate this definition over here. And we know that the codomain for f composite g is C. So for all C in C, the domain is still A. There exists an A in A such that this function f composite g will bring that A to this C. Okay. So we are given this, and we are also given this. Let's call it 1 and 2. And we want to show that G is onto, which is this. How do we go about proving that? If you look at what it means for G onto, you realize that we start with a universal quantifier for all B, which means something has to be true regardless of what B I choose from this capital B, right? So formally, we are right. Let's say we choose a B arbitrarily from this capital B. And then for simplicity, I think I'm gonna introduce a C. Okay, so let C in C, let's say C star, okay? C star in C to be the same, to be equals to f of B, because we know that this C in C, okay, we know that function f will bring B to C, okay? So we can have something like this. And we know that it's unique because it's 1 to 1. And what do we do next? So if you look at we only have two assumptions, 1 and 2, and 1 has nothing to do with C, but 2, look at this. For all C in C, something is true. For all C, including this C star, because this C star is also in C. So we know that there exists an A, let's say we call it A star, because I just want to make sure that I know who is who. There is an A star in A such that this is true, right? F composite G of A star is C star. But wait a minute, what is F composite G? By this definition of composition, F composite G is nothing but just G of A star and then followed by F. Right? And what is C star? C star is nothing but what we defined just now is F of B. This look very familiar, right? Which is by 1, right? Because we have, if the output of f is the same, means the input must be the same, right? The output is the same, means the input must be the same. So by 1, we know that g of a star equals to b, which is exactly what we wanted to prove, isn't it? Like g of a equals to b. Just that we are very specific about in this case because we choose a particular b. But don't forget that we choose it arbitrarily. So since I just gonna since b is arbitrary, we chose it arbitrarily. So for all b in b, we can find an a that satisfies that, right? There exists an a in a such that g of a equals to b. And this, by the definition of onto, show that g is onto. End of proof. This is a very interesting result that if we have a composite function that is onto, and we know that the outside function is 1-to-1, this means the inside function must be onto. Thank you.